Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we have a problem. We want to talk about three quantities: time, distance, and mass. When we talk about physics, one thing we do is we measure lots and lots of things. Now, by the way, we measure more than time, distance, and mass. But these are the big three, at least at the beginning of the school year. Later on, we're going to measure things like electrical currents and things like that that are measured differently. But time is usually measured in seconds. Now, it could be in minutes and hours and days and years and all that kind of stuff, of course. But time, the base unit that we're going to use is seconds. Distance is meters, okay, abbreviated M. And mass is kilograms, not grams. Now, of course, it could be measured in pounds and all these kinds of things, but these are going to be the basis of all the sort of the equations and the mathy stuff that we're going to do in our introductory physics class. Just seconds, meters, and kilograms. And you can put some of them together. You might be familiar with this, velocity. But what is velocity? Do you know this? It's like how fast your car drives. Usually you measure it in miles per hour. But in our case, that would be meters per second. You see, that's using both distance and time, right? And then there's something called acceleration. You may not know what acceleration is. We're going to have a whole bunch to learn about accelerations. A is equal to the distance divided by the time squared. So it's meters per second squared. And you can measure it in other things. I could just as well measure this in feet per day squared, but it'd still be acceleration. But in physics land, we use, it's actually called the SI system, the System International, kind of sort of like the metric system, but a little different. Because in the metric system, the base unit of mass is a gram, and in the SI system, it's actually a kilogram. So not a whole lot difference, but that's what we're going to be doing. So time, distance, and mass are super important when we talk about physics, and that's going to lead us to so many things. Now let's go deeper into the SI system. And the SI system is based upon a bunch of prefixes, and I'm going to put the prefixes over here. So we're going to call this the base unit. And it just doesn't have, and this could be like a gram, it could be a gram, it could be a meter, something like that. And it could be other things. But then we can have a bigger unit, and that's called kilo. All right, and a kilo means 1,000. All right, and then we can have a mega, and that means a million. Now I'm going to write a million as 10 to the 6th. And then we can have a giga, and that's 10 to the 9th. And by the way, mega, capital M, kilo, little k, giga, capital G, and then even bigger, tera, and that's 10 to the 12th, and that's capital T. So that's the base, but we can get smaller too, and there are many other ones. I'm just going to give the ones I think most important. We can be smaller, and that would be a centi. And that's 1/100th, okay? And then we can go milli, and that's 1/1000th, by the way, little c, little m. And then we get smaller, we can say micro, and that's 1/1,000,000, tiny little bad boy. And that's a funny looking u, and then the smallest one we'll ever deal with is a nano, and that's 1/1,000,000,000th. 9 zeros, and that's an N. But these are kind of weird, writing them 10 to the 6th, that's a million, a billion, and a trillion. I think the better way to write these is to write them as equivalent expressions. And the best way to do that is to use the bigger unit as 1. Let me kind of explain. So if I want to write a conversion factor, right, for centis to wholes, I can say that 1 gram is equal to 100 centigrams. Because the centigrams is a smaller unit, the gram is the bigger unit. So you always put the number associated with the smaller unit. If I do the opposite here, like kilo, I could say if I have 1 kilogram, that's equal to 1,000 grams. Does that make sense? Because a gram is smaller, so the number 1,000 goes with that. On the bottom, I'm actually taking the number, if you will, on the bottom of the equation and putting it right here. Because then when I write it in a conversion sense, talk about this in a minute, you could just as well say 1 kilogram over 1,000 grams, because what's going on is that's actually the same measurement, right? 1,000 grams is equal to 1 kilogram, and from math, you know if you have the same number divided by the same number, they cancel. Now, numerically, that's like 1 in 1,000, but actually, because we have different units, these are two equivalent expressions. So make sure you know these, and ones that you are not familiar with and that we will use pretty significantly are probably these two. We won't use the bigger ones very often. We'll pretty much stay here from kilo down to nano, and mostly kilo, centa, and milli. That's going to be our main, and occasionally when we start talking about light and junk like that, we're going to learn more about micros and nanos. So that's the kind of the SI system and understanding. If you understand your prefixes, it makes life so much easier. There's other ones, there's like, 1/10 and 10 decas and all that stuff. Those are very rarely used, and so we won't worry too much about those. Hey Houston, we don't have a problem. This is super easy stuff. You've got this. We'll see you in class.